Chapter 5 Factors and Multiples with HCF and LCM. Preeti has 30 toffees in a jar. She wants to group them in different ways. How many toffees will be there in one group? How many groups will be there? Multiples. Tunu, the rabbit, and Chini, the bird, are going to school. Tunu jumps 3 steps at a time starting from 1. Color the number he jumps on in blue. Chini hops over 2 steps at a time starting from 1. Color the number she hops on in green. The number Tunu jumps on are 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33. These numbers are called multiples of 3. Write the number Chini hops over. There is no end to multiples as multiples are infinite. These numbers are called multiples of 2. 2, 4, 6. Factors. Shera, the king of the jungle, invited all the animals for his birthday party. The 12 peacocks who had come for the celebration presented a special dance performance on the occasion. They can perform on the stage in the following ways. One line of 12 peacocks. 1 multiplied by 12. 2 lines of 6 peacocks each. 2 multiplied by 6. 3 lines of 4 peacocks. 3 multiplied by 4. 1 multiplied by 12 equals to 12. 2 multiplied by 6 equals to 12. 3 multiplied by 4 equals to 12. So, 1, 12, 2, 6, 3, 4 are all the numbers we multiplied to get 12. We can say that 1, 2, 3, 4, 6, 12 are all the factors of 12. When 2 or more numbers are multiplied, we get the product. The numbers that are multiplied to find a product are called its factors. Here, 3 and 4 are factors of 12. Factor is a number that divides a given number without leaving a remainder. Properties of factors. Look at the factors of 12. 1. 1 is its smallest factor. 1 is the smallest factor of every number. 2. 12 is the greatest factor. The biggest factor of a number is the number itself. 3. Every factor of 12 is less than or equal to 12. The factors of a number are equal to or less than the number. 4. Every number except 1 has at least 2 factors, 1 and the number itself. 5. A number has limited number of factors. 1 is the only number which has only 1 factor. Finding factors using multiplication. We can find factors of a number by multiplication. Example 1. Find the factors of 14. We can express 14 as a product of 2 factors. To do so, start by multiplying with 1, then 2 and continue finding the factors. We see that there is no number which when multiplied by 3, 4, 5, 6 gives 14. So 3, 4, 5, 6 are not the factors of 14. Stop at 7 as we already found 7 to be a factor of 14. 1, 2, 7, 14 are the factors of 14. Using division. We can also find factors by using division. Example 2. 20 elephants are going to the lake for bathing. They are moving in groups. What are the different number of equal groups they can make? If they move in one group, there will be 20 elephants in one group. If they move in 2 groups, then there will be 10 elephants in each group. They cannot move in 3 groups as 3 cannot be divided by 20 without remainder. If they move in 4 groups, then there will be 5 elephants in each group. If they move in 5 groups, then there will be 4 elephants in each group. So, the factors of 20 are 1, 2, 4, 5, 10 and 20. Example 3. Find out if A. 3 is a factor of 57. Answer: 57 is exactly divisible by 3. So 3 is a factor of 57. When we divide a number by another number and there is no remainder, then divisor and quotient are factors of dividend. Here 3 divisor and 19 quotient are factors of 57 dividend. Common factors. Example 4. Pinky, the squirrel, has a collection of 12 walnuts and 21 groundnuts. She wants to arrange them in equal groups. How many types of equal groups can she make so that each group has only same kind of nuts? Factors of 12. Factors of 21. Factors of 12. 1 multiplied by 12, 2 multiplied by 6, 3 multiplied by 4. Factors of 21. 1 multiplied by 21, 3 multiplied by 7. The factors of 12 are 1, 2, 3, 4, 6 and 12. The factors of 21 are 1, 3, 7 and 21. The common factors of 12 and 21 are 1 and 3. Pinky can make groups of 1 or 3 nuts each. Each group will have only one kind of nut, walnut or groundnut. Types of groups possible are 1 groundnut, 1 walnut, 3 groundnuts, 3 walnuts. Example 5. Find the common factors of 26 and 32. Factors of 26. 1, 2, 13, 26. 1 multiplied by 26, 2 multiplied by 13. Factors of 32. 1 multiplied by 32, 2 multiplied by 16, 4 multiplied by 8. 1, 2, 4, 8, 16, 32. Factors of 26. Factors of 32. Common factors of 26 and 32. The factors of 26 are 1, 2, 13 and 26. The factors of 32 are 1, 2, 4, 8, 16 and 32. Answer: the common factors of 26 and 32 are 1 and 2. Properties of multiples. The first multiple of every number is the number itself. Example: first multiple of 2 is 2 itself. Every number is a multiple of 1. Example: 1 multiplied by 2 equals to 2. 1 multiplied by 56 equals to 56. Every multiple of a number is greater than or equal to the number itself. Example: multiples of 2 are 2, 4, 6, 8 and so on. Multiples of a number are infinite. When 2 or more numbers are multiplied, the product is called the multiple of each of those numbers. 2 multiplied by 6 equals to 12. 12 is a multiple of 2. 12 is a multiple of 6. Finding multiples. To find the multiples of a number, multiply the number by 1, 2, 3, 4 and so on. Example 6. Mama Bear is very fond of eating fish. She is eating every fourth fish. Which fish would she eat? Multiply 4 by 1, 2, 3, 4 and 5. 4 multiplied by 1 equals to 4. 4 multiplied by 2 equals to 8. 4 multiplied by 3 equals to 12. 4 multiplied by 4 equals to 16. 4 multiplied by 5 equals to 20. The first 5 multiples of 4 are 4, 8, 12, 16 and 20. She would eat 4th, 8th, 12th, 16th and 20th fish. Example 7. Bunny is hungry. His mother has kept carrots on the dining table. He has to jump on every 6th tile. Find the tiles he steps on. Which are the first 4 multiples of 6 to get the carrots? 6 multiplied by 1 equals to 6. 6 multiplied by 2 equals to 12. 6 multiplied by 3 equals to 18. 6 multiplied by 4 equals to 24. He steps on 6th, 12th, 18th and 24th tile. To get the carrots, as the first 4 multiples of 6 are 6, 12, 18 and 24. To find out whether one number is a multiple of another, Example 8. Is 29 a multiple of 7? If there is a remainder, then the number is not exactly divisible by the other number. 29 is not exactly divisible by 7. So, 29 is not a multiple of 7. 29 does not appear as the product in the table of 7. So, it is not a multiple of 7. Example 9. Find the first 4 multiples of 9 that are even. The first 4 even numbers are 2, 4, 6 and 8. So, 9 multiplied by 2 equals to 18. 9 multiplied by 4 equals to 36. 9 multiplied by 6 equals to 54. 9 multiplied by 8 equals to 72. Numbers that have digits 0, 2, 4, 6, 8 in their ones place are even numbers. When divided by 2, they leave no remainder. Answer: the first 4 multiples of 9 that are even are 18, 36, 54 and 72. Example 10. Find the first 4 multiples of 9 that are odd. The first 4 odd numbers are 1, 3, 5 and 7. So, 9 multiplied by 1 equals to 9, 9 multiplied by 3 equals to 27, 9 multiplied by 5 equals to 45, 9 multiplied by 7 equals to 63. Odd numbers cannot be divided exactly by 2. The last digit of an odd number is 1, 3, 5, 7 or 9. Answer: the first 4 multiples of 9 that are odd are 9, 27, 45 and 63. Example 11. Is 77 a multiple of 7? 77 is exactly divisible by 7 as it leaves no remainder. Answer: 77 is a multiple of 7. If no remainder is left after division, then the number is exactly divisible by the other number and is a multiple of that number. Common multiples. Mama duck is taking baby duck to school. Mama jumps over 3 steps while the baby duck jumps over 2 steps at a time. Let's draw their steps on the number line. Mama duck jumps on multiples of 3, 6, 9, 12, 15 and so on. Baby duck jumps on multiples of 2, 4, 6, 8, 10, 12, 14, 16 and so on. We can see that both of them jumped on 6, 12. A number that is a multiple of 2 or more numbers is called a common multiple of those numbers. So, the common multiples of 2 and 3 are 6, 12 and so on. Example 12. Rani and Munni. The butterflies are collecting nectar from the flowers. Rani is visiting every 3rd flower, whereas Munni is visiting every 5th flower. Show on the number line the flower they both will visit. Multiples of 3. 6, 9, 12, 15, 18, 21, 24, 27, 30 and so on. Multiples of 5. 10, 15, 20, 25, 30 and so on. They both visited 15th flower then 30th flower. The common multiples of 3 and 5 are 15, 30 and so on. Example 13. Find the first 3 common multiples of 4 and 6. The multiples of 4 are 4, 8, 12, 16, 20, 24, 28, 32, 36, 40 and so on. The multiples of 6 are 6, 12, 18, 24, 30, 36, 42, 48, 54, 60 and so on. First 3 common multiples of 4 and 6 are 12, 24 and 36. Prime and composite numbers. Observe the following numbers and their factors. We know 1 is a factor of every number. Every number is a factor of itself. Numbers like 2, 3, 5, 7 have only 2 factors, 1 and the number itself. Such numbers are called prime numbers. Numbers like 4, 6, 8, 9, 10 have more than 2 factors. Such numbers are called composite numbers. 1 is neither prime nor composite and it has only one factor. Sieve of Eratosthenes. Eratosthenes, a Greek mathematician, found a method of locating prime numbers from 1 to 100. This is known as sieve of Eratosthenes. Sieve is the tea strainer used to separate tea leaves from tea. Similarly, the sieve of Eratosthenes separates out prime numbers. Let's find out prime numbers between 1 to 50 by this method. 1. Cross out 1 as it is neither prime nor composite. 2. Circle 2. Cross out all the multiples of 2. Circle 3. Cross out all the multiples of 3. Circle 5. Cross out all the multiples of 5. Circle 7. Cross out all the multiplies of 7. All the numbers that are circled are prime numbers between 1 to 50. All cross numbers except 1 are composite numbers. Prime factorization. All composite numbers can be broken up into their factors. 12, 2 and 6, 6, 2 and 3. Prime factorization of 12 equals to 2 multiplied by 2 multiplied by 3. We do not use 1 in prime factorization as 1 is not a prime number. The method in which the factors of a number are expressed only in prime numbers is called prime factorization of the number. Factor tree method. First, the number is factorized by dividing it by its smallest prime factor. Then it is factorized repeatedly until all the factors become prime. Example 14. Write the prime factorization of 48 by the factor tree method. Step 1. Divide the number by its smallest prime factor. 48 divided by 2. Step 2. Divide 24 by 2. 24 divided by 2 equals to 12. Step 3. Divide 12 by 2. 12 divided by 2 equals to 6. Step 4. Divide 6 by 2. 6 divided by 2 equals to 3. Step 5. Stop when the last two factors are prime. Answer. Prime factorization of 48 equals to 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 3. Division method. This is another method of prime factorization where a number is repeatedly divided by prime numbers. Example 15. Find the prime factorization of 16 by division method. Step 1. Divide 16 by 2. Write the quotient 8 below 16. Step 2. Divide 8 by 2. Write the quotient 4 below 8. Step 3. Divide 4 by 2. Write the quotient 2 below 4. Step 4. Stop as quotient 2 is a prime number. Prime factorization of 16 equals to 2 multiplied by 2 multiplied by 2 multiplied by 2. Example 16. Find the prime factorization of 75. Prime factorization of 75 equals to 3 multiplied by 5 multiplied by 5. Use those prime numbers for division which are factors of the given number. Highest common factor. HCF. Finding HCF by listing common factors. Highest common factor of two numbers is the greatest number that divides both the numbers without leaving a remainder. Example 17. Kuchu, the tortoise, is very fond of reading. He has 32 short story books and 24 books of poems. He wants to arrange his books in equal groups, but each group should have short story books or poem books only. What is the greatest number of books that he can have in each group? Factor of 24. 1, 2, 3, 4, 6, 8, 12, 24. Factors of 32. 1, 2, 4, 8, 16, 32. Common factors of 24 and 32 are 1, 2, 4 and 8. Kuchu can make groups of 1 or 2 or 4 or 8 books each. to have one type of book in each group. 8 is the greatest factor out of these. So, the HCF of 24 and 32 is 8. Greatest number of books in each group equals to 8. Finding HCF by prime factorization. Example 18. Find the HCF of 15 and 45 by prime factorization. The HCF of the given numbers cannot be bigger than any of the given number. 15 equals to 3 multiplied by 5. 45 equals to 3 multiplied by 3 multiplied by 5. Common prime factors of 15 and 45 are 3 and 5. Multiply the common prime factors to get the HCF. HCF equals to 3 multiplied by 5 equals to 15. Therefore, HCF of 15 and 45 is 15. Example 19. Find the HCF of 8, 10 and 12 by prime factorization. 8 equals to 2 multiplied by 2 multiplied by 2. 10 equals to 2 multiplied by 5. 12 equals to 2 multiplied by 2 multiplied by 3. Common prime factor equals to 2. Therefore, HCF of 8, 10, 12 equals to 2. Example 20. Find the HCF of 10, 14 and 25 by prime factorization. 10 equals to 2 multiplied by 5. 14 equals to 2 multiplied by 7. 25 equals to 5 multiplied by 5. There are no common prime factors for all the three numbers, so HCF is 1. HCF of 10, 14, 25 equals to 1. Example 21. Find the HCF of 7 and 11. 7 and 11 are prime numbers, so their HCF is 1. Therefore, HCF of 7 and 11 equals to 1. Lowest common multiple, LCM. The lowest common multiple, LCM, of two or more numbers is the lowest number that is completely divisible by each of the given numbers. We can find LCM of two or more numbers by A. Listing out common multiples. B. Using a number line. C. Prime factorization method. Finding LCM by listing out common multiples. Example 22. Tunu Rabbit and Tinny Squirrel are preparing for a hurdle race competition for sports day in the jungle. Tunu is jumping 4 stones at a time and Tinny is jumping 3 stones at a time. What is the first stone on which they will meet? At which stone will they meet again? Multiples of 4 equals to 4, 8, 12, 16, 20, 24, 28 and so on. Multiples of 3 equals to 3, 6, 9, 12, 15, 18, 21, 24, etc. Common multiples of 3 and 4 are 12, 24 and so on. Lowest common multiple of 3 and 4 is 12. So, 12 is the first stone on which they will meet. The lowest common multiple, LCM, here will tell us at which stone Bunu and Tinny will meet for the first time after start. The next time they will meet again at stone 24. Example 23. Find the LCM of 8 and 12. Multiples of 8 equals to 8, 16, 24, 32, 40, 48, 56, etc. Multiples of 12 equals to 12, 24, 36, 48, 60, etc. The common multiples of 8 and 12 are 24, 48 and so on. 24 is the lowest number among the common multiples of 8 and 12. Finding LCM using the number line. Find the LCM of 2 and 3 using the number line. Multiples of 2, multiples of 3. The place where the two multiples meet are the common multiples. Common multiples of 2 and 3 are 6, 12, etc. The smallest of these is the place where both multiples meet, that is 6. Answer: LCM of 2 and 3 is 6. Finding LCM by prime factorization. Example 25. Find the LCM of 6 and 8 by prime factorization method. To find the LCM by prime factorization, Step 1. Find the prime factors of 6. Step 2. Find the prime factors of 8. When a prime factor is common to both the number, it is taken only once. 6 equals to 2 multiply 3. 8 equals to 2 multiply by 2 multiply by 2. Step 3. Multiply the common factors taken only once and the factors that are not common. 2 multiply by 3 multiply by 2 multiply by 2 equals to 24. Answer: LCM of 6 and 8 is 24. Tests of divisibility. Tests of divisibility help us to find if a given number is divisible by another number or not, without actually dividing it. It also helps to find out factors of a number. A number is divisible by 2 if the last digit is 0, 2, 4, 6 or 8. Example: 10, 32, 34, 36, 48. 5. If the last digit is 0 or 5. Example: 10, 25. 10 if the last digit is 0. Example: 90, 170. 3. If the sum of the digit is divisible by 3. Example: 63. 6 plus 3 equals to 9. 9. If the sum of the digit is divisible by 9. Example: 72. 7 plus 2 equals to 9. Divisible by 9. 4. If the number formed by last two digits is divisible by 4 or ends with 0, 0. Example: 184. 84 is divisible by 4. 600 end in 0, 0. 6. If the number is divisible by both 2 and 3. Example: 216, which is divisible by 2 and 3 both. Example: 26. Is 315 divisible by 3? 3 plus 1 plus 5 equals to 9, which is divisible by 3. Answer: hence 315 is divisible by 3. Example 27. Show that 1728 is divisible by 4. Number formed by the last two digits is 28. 4 multiplied by 7 equals to 28. 28 is divisible by 4. Answer: hence 1728 is divisible by 4.